Hey there, in this video I'm going to discuss the transformations that we apply to sine and cosine. We're going to talk about the changes that they do to the graph and how to find them from the function. So first I want to refresh us on the basics for sine of x. So here we see one cycle of sine. We can see that the maximum, which is the highest point that sine reaches, is at 1, and the minimum is also at 1. Now the amplitude, this is a new term from this lesson. The amplitude is just talking about how high the graph goes from its midline up to its maximum, or even from its midline down to its minimum. So the amplitude here is 1, and this is going to become important when we start talking about the transformations that are occurring on the graph. The midline is the horizontal line that cuts the graph perfectly in half. So that happens in the basic function at y equals 0. And we're going to see that midline move around as we apply transformations as well. The period, we talked about this when we were introduced. This is the distance it takes for sine to complete a full cycle. So for the basic function of sine, the period is 2 pi. And the phase is the term that we use to describe the starting point and the ending point for one cycle of sine. So here the phase is at 0 and it ends at 2 pi. So those are the starting points and the ending points. Remember that the order of the key points for sine of x, it hits the midline, goes up to its maximum, hits the midline again, down to its minimum, and then back to the midline for it to complete one full cycle. The basics of cosine now, we've got similar features, but remember that cosine takes on a different shape in its cycle. And so the maximum here is still 1. Remember that it starts and ends at its maximum. The minimum is -1. And again, we see that occurring here right in the middle. And the amplitude is the same thing that it is for sine. It's that distance from the midline down to its minimum, or from the midline up to its maximum. The midline, again, same idea, is at y equals 0. That's what's cutting this graph perfectly in half horizontally. The period for cosine to complete one cycle is 2 pi. And for the basic graph of cosine, the phase is 0 to 2 pi. So that's the starting point and the ending point for its phase. Now, I want to talk about the transformations. Rather than taking the time to write all this down, this is a great screen to just screenshot and keep handy. But I just want to point out where we're going to see these transformations occur. Okay, so we can have a multiple in front of our trig function. Keep in mind that this can either be sine or cosine. So we could have a cosine of b times x plus c plus d. So multiplying something to the outside of our function is going to give you a vertical stretch or compression. We've done transformations before. These are all still the same that they were for basic functions. Okay, so the vertical stretch or compression impacts the amplitude. So that term amplitude is how tall the graph is from the midline to its max, or from the midline to its minimum, and that's what that value does. If a is greater than 1, it's a vertical stretch. And if a is between 0 and 1, meaning it's a fraction, then it's a vertical compression. This b value here, which is multiplying to the inside of the function, so we're multiplying something to x, this creates a horizontal stretch or compression. And this is going to change the period. So when we're dealing with functions that have been transformed, you're going to find the period by using the equation 2 pi over b, where b is that number being multiplied to x. So you'll want to keep this equation here handy so that you know how to find the period for a function. If b is greater than 1, the graph is horizontally compressed. So that means that it gets smushed together when b is greater than 1. And if b is between 0 and 1, then the graph gets horizontally stretched. So it gets pulled apart if b is less than 1. Okay, c here, which is adding or subtracting something to x, is a horizontal shift. So it moves it side to side, which means that it impacts the phase. So it tells you where that starting point is going to be, and then you could then determine what the ending point is from there. So it impacts the phase. If c is greater than 0, so that means if c is positive, then your graph is moving to the left. Remember, we've dealt with this in the past. And if c is less than 0, meaning c is negative, then the graph moves to the right. Okay. D, If you add something outside of the function to the very end, then that's a vertical shift, moving it up and down. And this is what's going to move the midline. So whatever that d value is, that's where your midline moves. Okay, if d is greater than 0, meaning d is positive, then we have the graph gets moved up. And if d is less than 0, meaning it's negative, then the graph gets moved down. So let's take a look at some examples where some of these have been applied, and we'll be able to see it actually happening. Okay, so first thing I notice in this graph here is that there's a multiple in front of it. And so this right here impacts the amplitude. So I know now that the graph of this function has an amplitude of 4. Okay, so the number that's being multiplied is a description of the amplitude for the graph. This means that sine of x is going to be 4 units above its midline and 4 units below its midline. The -2 on the inside of the function, this is a horizontal shift. So this impacts the period, or I'm sorry, the phase. So this means that sine is going to start at 2 instead of starting at 0 like it normally does. Okay. The period, if you notice, this doesn't have any kind of change to the x value. It's not being multiplied by anything. And so the period for sine is still 2 pi. So that's our standard period. There's nothing changing about that. And so the phase is going to start at 2, and then it's going to end at 2 plus 2 pi. Now, I will tell you this right here is not really important for your quiz. Your quiz doesn't specifically ask about the phase. I bring this up so that you know how to look for that starting point. And that's really the big idea behind the number here, is that that's the starting point of the cycle. So you're trying to identify that. So let's take a look at this graph and see what it looks like. Maybe you want to pause this video and try and graph it yourself first and see if you have a good understanding of it. So the graph here, we can see that sine of x starts at 2, right? It got moved over 2 units. We know that because we know that sine starts at the midline. So we would have to see that starting point. We then know that sine goes up to its maximum. It hits the midline again, down to its minimum, and then the midline again. So there's that full cycle of sine that's been completed over a period of 2 pi starting at 2. Okay, oh, and the amplitude, I need to mention the amplitude as well. We see that the maximum that it reaches is 4 and the minimum is -4. That's because of that multiple in the front. The next example I have for you here is cosine. So we're looking at negative cosine of 3x. Now we didn't talk about this in the initial slide, but we should recognize from other discussions about transformations that if there's a negative in the front of the function, then our function has been reflected. So this is a reflection across the x-axis. We can see that the amplitude isn't changing, so the amplitude is still 1, just like the basic function. Okay, now the period here, here's an example where the period changes because we can see that x is being multiplied by a value. And so the period, we always calculate using the expression 2 pi over b, where b is that number that's being multiplied. So now my period for this graph is going to be 2 pi over 3. So instead of it taking a total distance of 2 pi for cosine to go through its phase or full cycle, it's going to only take a distance of 2 pi over 3. Okay, the phase hasn't changed because, or the starting point I should say, hasn't changed because nothing's being added or subtracted. But now my phase ends at 2 pi over 3 because that's how long it takes for it to go through a full cycle. And then the midline isn't changing either, and so the midline is still at y equals 0. So pause this video, see if you can sketch this graph. And we should see something like this. So the reflection changes how cosine starts. So instead of it starting at its maximum, now cosine starts at its minimum because it's been reflected over the x-axis. We know that it then hits the 0, it goes up to its maximum, hits the 0 again, and then down to its minimum to complete its cycle. We see that it completes its cycle at 2 pi over 3 because the period of this graph has changed. Let's look at another example here and go through these same features. So starting with the amplitude, we can see that this graph of sine here has been multiplied by a value, And so now my amplitude is 2.5. So my graph is going to go up 2.5 from the midline and down 2.5 from the midline as well. We can talk about the period now. So the period is going to change as well because x is being multiplied by a value. And so remember that we always calculate the period using 2 pi over b, where b is that number being multiplied to x. And so this is 2 pi over pi, which is going to be reduced to 2. So this graph is only going to have a period of 2 as opposed to a period of 2 pi. Now the phase, this doesn't have anything being added or subtracted inside the function, so this is still going to start at 0 like a normal sine function or basic sine function. And now since the period is 2, that's where it's going to end. So it takes a total distance of 2 to go through a full cycle. Finally, let's talk about the midline. So the midline is changed by this number here at the end. And so we know that the midline is going to move down 3 units because of that minus 3. So now my midline is at y equals negative 3. So pause this video, take a moment looking at these features to see if you can sketch this graph. And here's the graph that we're looking at. So sine of x starts at the midline. Remember that midline got moved down to negative 3. And that's the starting point for sine. It goes up to its maximum. Since the amplitude is 2.5, that makes its maximum at negative 0.5. We can figure that out by adding, right? So negative 3 plus the amplitude, negative 3 plus 2.5 gives me negative 0.5. It goes back to the midline and then down to its minimum. The minimum here is at negative 5.5. Again, we can get that by subtracting. So negative 3 minus the amplitude. Negative 3 minus 2.5 is going to give me negative 5.5. And then sine goes back to the midline. And we can see that it completes this full cycle in a total distance of 2 because that's the period for this particular function. The last example I have for you in this video is one more cosine example. So we have 1/2 cosine of x minus pi over 2. The amplitude has been affected because it's being multiplied by a number here. And so the amplitude is 1/2 instead of 1. The period doesn't have any change being applied to it because x is not being multiplied by anything. So the period here is still going to be 2 pi. But you'll notice that this graph has been shifted horizontally. The x minus pi over 2 is a horizontal movement. And so now this is going to start at positive pi over 2. As I'm looking at this, I think I might have graphed this one wrong. With it starting at pi over 2, that means it's going to finish at 2.5 pi because we have to add the period to the start of that phase. And so it's going to end at 5 pi over 2. So we should be able to see our cosine cycle go through these, or start and end at these points here. And then the midline doesn't have any change applied to it because nothing's being added or subtracted at the end, so the midline is still at y equals 0. I recommend pausing this video to see if you can graph this first, and then take a look at the graph with me. So I did not do this wrong, but I didn't show enough of it, so that's the piece I did wrong there. All right, so here we've got cosine. We know that this cosine graph should start at pi over 2, and that's where the maximum is. So cosine starts at the max. It's there at pi over 2. Then cosine goes to the midline, which is at y equals 0. It goes down to its minimum. Which I should point out, the max and the minimum is at negative 0.5 and 0.5 because the amplitude is only 1/2. And then cosine goes to its 0, and then we would have seen it reach its maximum again at 5 pi over 2. So that's where I messed up. I should have included a larger graph. I apologize about that. And so we see that cosine goes through a complete cycle in a distance of 2 pi that is being covered from pi over 2 to 5 pi over 2. So hopefully these examples were helpful. Please reach out if you need more help with transformations. But take your time really looking at what you see in the graph and how to describe those features, because some of what you'll have to do on the quiz as well is looking at the graph to determine the function. So try to go backwards as well as you're practicing this. See you guys next week.